Good morning, everybody. Thank you for being here this morning with us in this class for the E3T electrical heater. It's a beautiful morning in California. Wherever you are this morning, East Coast, Central Time, or wherever you are, have a good morning. This class is going to be also monitored by Brad Duncan, that is going to be monitoring the question that you might have in your control panel. So if you have any questions, just send it. We are going to be responding to those questions throughout the class. Good morning, Brad.
Well, good morning, Ricardo. Thanks for having me in. Good morning, everyone. I'm riding shotgun today, so I'm going to be monitoring your questions. If you have questions during the presentation, you can type them in. If you look over at your dashboard, you'll see a place to type in questions, and I will monitor those. And if it's particularly interesting, maybe we'll bring it up in the course of the presentation.
Thank you. Okay, let's just start with this class. The agenda for today's class is a brief introduction, our sustainability message, technical requirements, installation, programming and control, troubleshooting, and live questions and answers. Basically, this is a level 2, level 3 class altogether. Okay. The training content, as a reminder to all our participants, the instruction provided in this training is intended for qualified and experienced professionals. If you're not qualified, please do not attempt to apply these instructions on your own. Let me bring to you our sustainability message. I would like to take a moment to state Raypak's commitment to developing and producing sustainable products. Raypak and our parent company, RIM, have established firm goals as we work toward substantial reductions in waste, both in our manufacturing processes and in our entire line of products. As we work toward our vision of designing for zero waste, we have developed a strategic framework with a specific target goals to be met by 2025. We are committed to developing and innovating intelligent products that reduce waste over the lifetime of the appliance, including the use of recycled and recyclable materials. We will endeavor to reduce greenhouse by 50% and achieve zero waste to landfill in our global manufacturing operation. We will train 250,000 plumbers, contractors, and technicians on sustainable product installations and recycling best practices. Why does this matter to you? Because your customers want to buy products from a company that values sustainability. 84% of the customers indicate that they prioritize purchasing a pool heater or a heat pump or an electrical heater from a brand that is committed to sustainability over one that is not. What can you do about that? Well, the key word is recycle. If you can use paperless billing, if you can use more tools that are encompassed with sustainability theme, do it, go for it. And also, if recycle try to recycle the old furnace that you are removing from the installation site, and try not to dispose it in whatever place you can see. That is our message, guys, for the sustainability. Okay. Certificate of attendance. A link is going to arrive by email in the next 24 hours. It's a basic certificate with your name. So if you need a certificate for CEUs, all what you need to do is send an email request to training@raypak.com, include the date and time of the class, perhaps your name also. We will send you a certificate which includes CEU hours. Okay. Okay, so let's start with this E3T. Basically, we start with the whole concept of wages, that is water, air, gas, electricity, and service. In our case, for the E3T, basically there is just water, electrical, and service clearances. That's it. That is the exactly what you need for this heater. So there are sorry, there are 4 capacities in our new electrical heater: 5.5 kilowatts, 11 kilowatts, 18 kilowatts, and 27 kilowatts, where you can choose from. Completely revamped and design and functionality. It's really totally different from what you have seen in the past for our electrical heaters. It's a completely new internal casing, new material for the elements, and more advanced technology. We utilize titanium heating elements and the 316 stainless steel that give the E3T the upper edge against the competition. Okay, especially for those applications on pool or spa where you are using chlorine generated by salt system. No more contactors, now it's solid state and flow sensor technology. Okay, as you see right there. Internal components for the unit. This is a pictorial for a 27 kilowatts. You can see on top of the whole chamber for the elements. Well, the elements 1, 2, 3. Manual high limits. That is the only safety that you might have. That is rated to 140 degrees. You have the LED display that is going to show you all income temperature, inlet temperature, outlet temperature, flow, and whatever message that the CPU is going to be sending to that display. The control knob where you're going to be monitoring your system. The terminal block where you make the connection for the high voltage, L1, L2 plus ground. Then we have the key element on this particular heater, the TRIAC 3 wire elements that are right here. Okay, the inlet sensor, because we monitor the inlet temperature, and the outlet sensor temperature. Remember, this is a flow sensor. It is not a flow switch. It is not a pressure switch. It's a flow sensor that actually, if you can imagine a propeller inside of that particular point. It's a propeller that when it starts to receive the minimum gallons per minute that we are about to see, then start to rotate, and it's going to stay like that for 1 minute without doing nothing. And then once that 1 minute has passed, then it's going to be sending a signal to the CPU. CPU start to move voltage around the unit. So let's start with water. The first recommendation is always water chemistry. Regardless that we have a stainless steel chamber for the elements and a titanium element, water chemistry is a big thing too. You know, if you have a hardness that is in excess of 400 ppm or total alkalinity more than 120 or excess of chlorine, chances are that you might do some damage to the element. We don't want that. Okay, so water chemistry is a key on this particular heater. Proper water flow through the unit is critical. So in the 5.5 and the 11 kilowatt, we have 1.5 MPT inlet and outlet connections, okay, along with those units that you see there, and that is going to allow us a max flow of 50 gallons per minute at 8 feet per second. Think about this. You need to have proper flow, but the proper velocity. If you start to go so fast on the velocity, chances are that what we are supposed to be doing in that particular chamber with the elements, that is the heat exchanging, is not going to happen. It's just going to be water passing through elements, but the water, that is the cold water that is coming from the pool, never is going to pick up the heat from the elements. In the other case of the 18 and the 27 kilowatts, we have 2-inch NPT connection. Okay? That is going to give us range of max 82 gallons per minute at 8 feet per second. Beyond those ranges, we're going to be in the need of an external bypass. We're going to be seeing this in a moment. So just to have completely a clear picture, what is going to be the minimum for all the units, and the max on the unit is 15 gallons per minute is the key as a minimum, and 60 gallons per minute is the max. If you are beyond that number of 60, then we recommend you to use an external bypass. Just keep in mind that the flow sensor is expecting to receive at least minimum of 15 gallons per minute. So if you do the proper bypass installation, as it should be the norm really. Anytime that you have a heater, you should put your flow meter, your bypass, and if you want a flow meter in the entrance of the unit. If you have a flow meter, you can monitor more the situation. But don't worry about that, because let's say that you don't have a flow meter, or you don't want to install a flow meter, the unit itself is going to give you that information. Okay. So the unit will not energize the element if the water flow is under 15 gallons per minute. Once the flow has been established completely, the element will energize, and there is a built-in 1 minute delay in the CPU. Okay. On the electrical side, okay, let's see this. There are a number of elements per kilowatts capacity for the units. For the 5.5, we have one element. For the 11, we have two. For the 18, we have two elements. And for the 3, we have, for the 27, we have 3 elements. Voltage for all of them is 240. No less than that, unit might not work properly. The power to all of them, as you see, is 5.5 kilowatts, 11 kilowatts, 18, and 27. Required breaker for the 5.5 is 30 and 30 amps, minimum and maximum. For the 11 is 60 and 60. For the 18 is 40 minimum, 50 max. And now we need 2 for the 18, and we're gonna see why 2. And for the 27, we have 3 breakers that are required that can be either 40 amps or 50 amps maximum. Think about the electrical service panel. What size do you have to have? You see it here at the bottom. You need to have 100 amps for the 5.5, 150 amps for the 11 kilowatts. For the 18 kilowatts, you need to have 150 amps. And for the 27, you need to have 200 amps. Okay? There is a key element on this electrical connection, and is the wire gauge. Okay, just keep in mind that you need to have the proper wire size for the specific unit. For example, for the 5.5 is number 10, for the 11 is number 6, for the 18 is number 8, and for the 27 is number 8. And we have number of wire set that is specific for every unit. For the 5.5 is 1, for the 11 is 1, for the 18 is 2, and for the 27 is 3. When we said wire set, we are referring to a set of 3 cables, L1, L2, and ground. Okay, so not just when we say wire set, just keep in mind that it's a set that is going to be comprised of 3 cables. Okay, breaker type is going to be a double pole breaker for all of them. Breaker quantity for each of the model is going to be 1 for the 5.5, 1 for the 11, 2 for the 18 kilowatts, and 3 for the 27 kilowatts. Okay, make sure the incoming voltage is what the required number is specified in the manual. See, in this test that they are doing, the complaint was no, my unit is not working well. It's reading 207. For sure, the unit is not going to be working properly. 240 is the magic number. This is exactly how you're going to be making the connection. That particular schematic, you can find it in our menu. If you can see here, L1, the 5.5 kilowatts, you have ground, L1, L2. going connected to a double pole breaker. For the 11, you have L1, L2, a double pole breaker of 60, and you have ground. For the 18 kilowatts, now you have two L1s and two L2s, all of them connected to their respective double pole breaker. You have two 240s and 240s. Well, it's a double one, and two grounds. So that's the reason why I was referring as a wire set. And for the 27, now you start to see three sets. You have three grounds, three L1s, and three L2, all of them connected to their double pole breaker, those sets of L1, L2. Okay. This is the point of entrance for the L1, L2. You see it right here. And this is the bar for the ground connections. All of them are going to be beneath the CPU. That is the, let's say, the command center for this unit. The element. The element has a resistance of some value of ohms. For example, for the 5.5 kilowatts, you have 9.994 ohms. And for the 11 kilowatts, you have 1152 ohms resistance. For the 18 kilowatts, you have 6.1 ohms. And for the 27, you have 7.11 ohms. Also, there is draw that is gonna, every element is gonna be taking from for electricity. For the 5.5 and the 11, there is gonna be 22.9 amps that is gonna draw each element. And for the 18 kilowatts and 27, all the elements are going to be drawing 37.5 amps. Okay, just keep in mind that. So basically, this unit is about proper electricity voltage and proper water flow. Okay, also the manual high limit. Each element has its own manual high limits that will trip if exceed 140 degrees in temperature. When you can have that, we're gonna see it. We're gonna see it in the next section, but let's advance on that one. Anytime that you have lack of water, improper water flow, chances are that that particular high limit, it will trip. So just reset it on top, but you need to find out what is the cause of that particular situation that is causing the high limit to trip off. Also, the 27 kilowatts is the only one that is equipped with inlet and outlet thermistor for the chamber. So we are monitoring what is the temperature of the chamber where the three elements are inside. Key on this design was the incorporation of the TRIAC. TRIAC stands for trial for alternating current. And those are switches that are the key in modulating the voltage. There are three terminals electronic components that conduct the current in either direction when triggered. How they get triggered? Either by gate and anode 2 or by gate and anode 1. So current can be going this way or that way. That's the reason why you see the sign right here, and it's going to be modulating the voltage like this. So basically, that's the key design that we incorporate, and that's the reason why the E3T is a really far advanced electrical heater over the competition. Electric heater diagrams is exactly like this. Please make a note. This is L2 and exactly appears in the manual like a L1, L1, but there is no way that you can have two L1s. You need to have L1 and L2 in ground. Then goes to high limit 2, high limit 1, goes to the element, immediately goes to the CPU where the point of connection is going to be the BH2. Then we have the flow sensor that is going to be connected to CM4. Then on BH3 and BH4, you have the water inlet sensor and the water outlet sensor. Both of them are rated to 150K sensors. Then the point of remote control wire is going to be at CN8, and we're going to see what exactly is this. Okay. For the 27 kilowatts, you're also going to have the same diagram, but it's going to be amplified in point of connections. Now you have L2, L1, L2, L1, L2, L1, and perhaps you're going to have 3 wires for ground, three high limits, 3 elements, and your flow sensor, your water inlet sensor, inlet and outlet, but also there is going to be an extra sensor right here that is going to be the thermistor of the chamber and the outlet thermistor of the chamber. And those thermistors are going to be 10K sensors. So just keep in check that the water inlet sensor is 150K inlet and outlet, and the inlet and outlet thermistor is 10K, totally different. And once again, the remote control wire. Okay, spaces. The only recommendation on this one is leave on the top 18 inches, on the side 6 inches. Remember, you need to have enough space to, if you require a bypass, then you're gonna have the space to do so, okay? So that's the reason why we are saying that. Besides that, do not install the unit in very confined space. Do not put it upside down, it's not gonna work. And besides, do not make the connection in a reverse way where the inlet is. You're gonna be connecting the outlet connection going to the unit, and it's not gonna work. Chances are, remember that there is a flow sensor that needs to sense those 15 gallons per minute in order to operate properly. So you might think, no, that is not gonna happen. Happens, happens sometimes. Okay, now let's start with the, looks to me like there is a question over here. Consider the space for someone to fit in the area to fix in the future. Yes, you are right, Davis. Remember, you need to leave space, especially if you are trying to do service to the unit. Happens that recently I saw an installation where the heater, an electrical heater, was installed like a dangling from some metal attached to a wall. And I said, where are you going to do the service on this? And they said, no, no, don't worry about this. Yes, it worries. You cannot, this is not a Muro instant water heater. It's supposed to be on solid base. So thank you for that observation. Yes, you need to leave a space for that. Okay, you need to leave the proper space for service. So now we're going to see the level 3, that is the programming and troubleshooting. Okay, what's going on here? Okay, the unit can be used all year round. The user must make sure that the pump is not disengaged to allow it to run until the desired temperature setting is reached. There is sometimes a tendency, I'm not saying that all of them, but some users saying, no, I don't want to have my filtration pump running more than 4 hours, but they forgot to turn off the unit. That is not gonna do any good to the unit. Also, the unit is going to be only working when there is 15 gallons per minute. If you want to know what is the flow rate, all what you need to do is press and hold the knob for 5 seconds, and immediately you're going to see right here F, whatever flow do you have, F15, F25. That is an indication that you have, let's say that you have F25, it's an indication that you have 25 gallons per minute. The unit, as I mentioned before, has a 1-minute build time delay, and that is to protect it from air in the lines to avoid burning out the elements. When you can get air in the unit, I mean, not in the unit, but in the plumbing. Let's say that you have a skimmer that the water level of the pool not really, well, it's below the skimmer. Chances are that you're going to be sucking a lot of air and a little bit of water. That's when air starts to get trapped and start to create bubbles in the plumbing. Okay. The digital control temperature setting is easy. It's in the front panel, and you can easily set between 40 and 104 degrees in 1 degree increment by simply turning the knob to the high position. The heater can be turned off by pushing the control knob once, but also if you hold the knob for 2 seconds, I mean, you push it and hold it for 2 seconds, you're gonna switch between Fahrenheit and Celsius. If there is anybody in this class attending from Canada or from Latin America, that Celsius is the preferred unit for temperature. Okay, so you can do that, and vice versa. You can go back to Fahrenheit, doing exactly the same procedure. Okay, you're gonna find a label exactly like that, where it says when necessary, add pull and spot remote switch here. This is the connection where you make the ability for the unit to get connected to an automation system. What kind of automation system? Any automation that might be in the market that are coming from our competitors, like Fluidra, like Hayward, Pentair, Balboa, or anybody that might have that. Okay, is the supply two wire connectors goes right here. Or what you need to do is disconnect that one and make the connection to the wires that you're gonna bring from the automation system. Just make sure that at the automation system, there are two types of connections. One is gonna be for gas heater, and the other one is gonna show electric heater. So you make the connection where it says electric heater in order to follow the proper flow of voltage inside of the automation system. Once you do that, you don't have to program the unit to work with the remote control. Just leave the unit on at the desired temperature. But if you want, my recommendation will be take the unit all the way to 104. Why? Because most of the automation system, they have their own temperature sensor. So if the automation system is the one that is commanding the actions, or the unit is just gonna be obeying whatever instruction is coming from the automation system. Simply like that. So when the remote control does not send any signal to the unit, E5 fault is going to appear on the display. It's not a fault, it's simply it's not closing the circuit. Right here, if you see this jumper, basically is the voltage. But if this voltage is getting interrupted because at that particular point, the temperature sensor of the automation system is not seeing a need for call for heat, well, no signal is going to be coming from the automation system. Nothing is going to happen. E5 is going to appear on the display. Let's start with the troubleshooting. Let's see the first problem. Nothing happens when the thermostat is turned on. First cause of that problem might be low flow. Check your filter. Check that the filter it has been properly bagwashed. If this is a sand filter, if you have a cartridge filter, make sure that you remember when was the last time you did service to the cartridge. Maybe you need to replace the cartridge. Also, check the pump. Check that the impeller does not have any elements, especially here in California. I heard that sometimes trees, when there is a pine tree, those small things start to go into the pool and get trapped on the impellers. So that is going to be prohibiting the pump to deliver the proper flow to the filter, and therefore going to the unit. If you have a 2-speed pump, make sure that you put it on the high speed. If you want to know after that you put it on the high speed, if you are receiving the proper flow, once again, press and hold the knob for 5 seconds to make sure that the flow rate displayed on the screen is at least 15 gallons per minute. Remember, 50 and 60 gallons per minute is your perfect range for all the units to work properly. Okay, another possible cause for nothing happened when the thermostat is turned on. High limit. Or what you need to do is push the reset button, okay, on top of the element. But that is an indication that uh, the elements went beyond 140 degrees, and you need to find out why is that. Most of the time is lack of the proper flow. Okay, thermostat not calling for heat. That might be another possible cause. So what you need to do is turn the thermostat to higher temperature. Okay, let's see another possible problem. It takes a long time to hit the spot. Well, maybe there is a low input voltage. Remember, 240 is the key. So what you need to do is call the electrical company to bring the proper voltage to the service panel where you are connecting the heater. Maybe you have an undersized heater. You need to calculate the temperature in high rise per hour. That is equal to the heater input in kilowatt multiplied by 410, that is a constant, divided by the spa gallonage. This does not take in consideration the account heat loss due to the weather. Remember, anytime that you have a spa that is exposed to high wind conditions, all the heat that you've been gaining from the heater, if you don't have the proper cover, especially at night, that heat is gonna dissipate immediately. That's the reason why the next cause of that particular situation is heat loss from poor weather conditions, such as maybe it's cold outside or there is such a high wind, so you need to use an spa cover for that particular situation. Also, why it might take a long time to heat the spa? You have a defective heating element. Please forget about that. Call an electrician. You need to call us. You need to call Raypak, and we're going to refer you to our proper warranty station to take care of the situation. Perhaps if the condition is not anything that is related to the unit itself and not to an external situation. If you have a defective heating element, but it's caused by excess of acid that we're going to see in the next slide, then that is a different situation. Okay. Another possible problem, the spa does not reach the temperature. Once again, low flow. Check the filter, check the skimmer basket, check the pump. Another problem, heating element continuously is burning out. You have high input voltage that is beyond the 240. Now, once again, you need to call the electrical company. Poor water chemistry. Remember that I mentioned that I showed the chart what the chemistry on the water needs to be in order not to do damage to the element. Just keep in mind that any chemical that you add to the unit and you have a unit that is reaching temperature of 104, chances are that might be a chemical reaction if that chemical has been added in excess. Okay, another possible cause for this continually heating element continuously burning out might be a heating element split open. That the solution for that is you did an over acid condition. You need to watch the pH and add the acid slowly. Okay, remember that you are adding the acid to the pool, to the whole mass of water in the pool, not to the skimmer, not through the skim. Okay, another problem might be fuses blown or circuit breaker opens. Well, there is a shorted heating element, you need to replace it. Okay, and you have an undersized wire, you need to replace for the right one. Remember that I explained what kind of size of wire do you need to have for the unit, for the specific kilowatts unit that you are installing in your spa or pool application. Okay. Also, you can do the water sensor resistance. That is 150K for the inlet outlet sensor. All you need to do is know the temperature in the pool and the resistance. And how do you get the resistance number? well, you connect your meter, and then you're gonna get this reading based on the temperature that you have in the water. Okay. For the thermistor chamber sensor, remember that this is only for the 27 kilowatts. There is also the same test. For a specific temperature, you're gonna have a reading of ohms on those particular sensors for the 10K sensor. Okay. That closes our formal presentations. Now we will open the lines to answer your questions. Just go to your control panel. I'm gonna unmute everybody, and you can see that there is a orange microphone. Just push that yourself. Everybody is on mute right now if you have any questions. Any questions? No? Okay. Well, if there is no any questions, guys, we would like to hear from you at training@raypak.com. But also, please take our survey after we end the webinar. If you stay on the line, you will have the opportunity to answer just 2 questions. There will also be a link in your follow-up email for that particular survey. Thank you guys for being in this class. Thank you, Brad. See you later for the other class. Have a great day, guys.
Thanks, Ricardo. Good morning, everyone.